Welcome to Code Mastery. William Shakespeare once said, "A rose by any other name would still smell as sweet." William Shakespeare obviously never wrote code. I'm going to try and talk about what doesn't work with naming, what doesn't work with refactoring, how we can use naming to drive refactoring, and offer an approach that has worked for me and hopefully will work for you. Who am I? I'm Matt. I'm a senior developer. I write PHP, I write Elixir, I write some C++. I have a focus on metrics-driven development. All of my examples will be in Elixir. I apologize for anyone who doesn't read it, but it's quite readable anyway. I have many opinions. Today, you should only hear one of them, unless we meet in the pub afterwards. So, there's three common approaches that I hear when I talk about rewrites. One of them I call the post-conference blues, which is when you've just seen all these new shiny technologies at the conference that you're not using, and someone, usually at the bar, proposes we should rewrite the entire monolith as a CQRS, ES, microservices application. This approach is interesting. Has anyone wanted to do this? Has anyone ever had a monolith that they really like to totally rewrite? Put your hands up. Has anyone ever proposed it to the business? Keep your hands up. Has anyone ever had the business say yes? Keep your hands up. Has anyone deployed it? Keep your hands up. Well, that's a small proportion. The reason this doesn't work is because it's a methodology that we're quite used to. It's called waterfall, where we propose the entire project up front. We know all of the requirements up front, and we have no agility. And usually we have to develop it in line with adding business value to the old system. The second approach is the bury your heads in the sand and pretend that there's no problem. That's quite common. It's not so much that people will say that there is no tech debt, although I have heard it. It's more that people will just say that it's not really that much of a problem or that it's not a high priority. And the third one is we'll deal with it later. But as Garth Brooks told us, tomorrow never comes. I'm going to propose to you an idea that you can do in 10 to 20 minutes, maybe an hour a week, that you can fit into your normal workflow that will make your code better. Will make your old code better. So what does work? For me, what's worked is attrition, which is you take a problem and you hack away at it. So it's an incremental approach. It's not drastic. In every ticket that you pick up, endeavor to make the code that you touch better. Seems like an uphill challenge, but if you have 20 devs, each person doing 2 tickets a week, that's 2,000 changes a year that you can make that improve your code. And most importantly, it doesn't disrupt the workflow, i.e. everything you're doing is still adding business value. I'll give you some steps to improve code in 2 to 30 minutes each time, so 2 to 30 minutes per ticket. And if you get time to do multiple steps, obviously do them, but if you don't, it's good as well. So, naming is a tool. Naming is not purely aesthetic. The names that you put on your variables, on your data structures, and on your functions tell you the responsibilities of those variables, data structures, and functions. Therefore, if you have good code, like nice modern code, quite often when you pick a ticket up, you can read that code, not have to read through every function, be able to find the part that you need to change very quickly, and go into it and change it. When you have legacy code, quite often you have code that you have to go into every sub-function because they're poorly named, that you have to look at a lot of what it's doing and try and work out what it's doing. And the idea is that by using naming, we can split the code up into logical parts that make it a lot easier to work with in future and therefore make it more maintainable. So I've identified 7 steps in naming. I think probably different people will disagree that some of them are steps or split them up even further. If you've got any good ideas, please tell me. But the idea is that these steps are easy to define and easy to remember so that you can sort of look at any piece of code and say that's in that category, that's in that category, and immediately know where you can make an improvement. So the first step of naming is not naming. This would be, for example, large blocks of logical code that have no labeling on. One of the fastest things you can do to improve that piece of code is to drag it out into a protected or private function and name it. So that way the next person who comes along doesn't have to work out what it does because the name that you put on the function tells them what it does. Similarly with variables, if you've got something that's kind of doing a calculation and you're just putting that in a variable called a or x, which is common in some legacy, if you put a name on that that explains what it's holding, that immediately adds value. If you find yourself asking, my general rule is if I find myself asking what does this do and having to work out what a block of code does, that probably means it needs a better name or it needs a name. So this is an example. What does this do? Can anyone tell me? Okay, so the function name is ambiguous. The function parameter is ambiguous. The 1.2, I have no idea what that does. The reduce, I know what that does, but I don't know what x is within it. I'm guessing it's an item, but what's an item? Just by adding names, all I've done here is split out two parts of the code and added some names. You can immediately tell what this is doing. If you pick up a ticket and you see that second one, you'll immediately know what you're working on. So that's an example of the first step is just introduce naming and make it clear what you're doing. So the second step is nonsense names. I'm not sure if you can see the text. It's not very good. The second step is nonsense names, and these are names that have little or no value. So some of them are actually harmful. Names which deceive are in many ways worse than names that are not there at all. So if you have a function called get something and it's actually doing 4 computations and deleting something and then getting something, or creating something and then getting something, that's actually actively harmful because when I'm reading the code, I assume that it gets something. We break these down into 3 types of nonsense names. You have low value names, which are kind of where something is named, but the name doesn't fully communicate what's there. So for example, if I have something called user, but it's actually a user's account, or a user in a specific context, but that context isn't told to me in namespacing or in naming, then I'm not immediately able to discern what I'm working with from looking at the name. 0 value names are just rubbish. They're functions called function or execute or anything else that's not particularly helpful. They're variables called x or array or object, and most of us have probably seen one of those at some point. And then there are, as I said, dangerous names, negative value names. These violate the principle of least astonishment, and they are actively harmful because you can make assumptions based on the name that are wrong. I'm going to take a quick diversion to introduce the principle of least astonishment, which Carlos over there actually told me about. I'm really happy because I kind of thought of it as an idea for a long time, but I'm happy that it has a name because that fits into my interest in names. But the principle is basically that the design should meet the expectation of the user. And names which are misleading, as I said, are worse than names which are not there at all. So fixing nonsense names, where to start? This is an example of what I would consider a few nonsense names. So on the left you've got the module catalog, which is got a function called new item. What's an item? Is it a product? Is it a category? Is it a single unit of stock in that product? You don't really know because it's poorly named. New item destroys an item, potentially, if delete destroys an item. Has and add, I can kind of guess what those do, but they're probably not well named either, because it probably should be something like has product or store product or something that gives some context to what we're doing. This is my attempt at a better version. The important thing to note here is that this is not a good version. This is not a final version. This is one increment higher than what we had before. So this is moving from nonsense names to, I think, honest names. This is it's an incremental process, so the point is that you can do as many increments as you can get in a specific session, but don't feel compelled to take it all the way if you don't have time for that on your ticket. So next we have honest names. Honest names are not dangerous. Honest names communicate fairly well what they contain, but they still don't really help us to refactor code, and that's what we're looking at, is how can we use names to drive refactoring. So what we need to look at next is what are these names hiding? What is this get function hiding? Why is it 30 lines long? And then what we're looking at is finding what it's hiding and putting that in the name. And quite often there you'll end up with some very verbose names, because the functions that you're naming are not ideal functions. They're things that you should be breaking up later on. So by giving them the verbose names, you can work out exactly what you need to break out. This example was not a function, this was a variable, but the variable user here contains a shopping cart. Potentially you may want to call it user and shopping cart. It's also not a dedicated data structure, so there's no expectation that it will contain a shopping cart from the name or from the class or struct. So by using this kind of renaming things and using these verbose names, you can immediately identify pieces of code that are doing far too much. I've got some examples on the next page. So these are some examples of functions that I've renamed. So validate password and register user in database. I mean, you can easily break that down into validate password and register user in database, two separate functions. Read from CLI, get medical record, and print to screen. I think that's quite easy to break down as well. So the idea with these names, as you can see, is that what you're trying to do is work out what you can break it down into, what the optimal units of code there are. Even if you don't have time to do that right now, you're putting that in front of the next person who can come along and do that, or you, next time you pick up a ticket in that area. So accurate naming is all about working out where we're violating single responsibility. The next step of the refactor is to break it down. Take your long-named complex functions, long-named data structures, and work out how you can break them down into logical units that have a single identifiable responsibility. In this instance, I had one that has 3 parts: validate and change password if user supplies correct password, and just broke it down into validate password, is valid password, is current password, and change user password. And the other thing is that when I've broken them down into these, they're much easier to test, because I have 1 fail condition per function instead of 3 fail conditions, and all of the combinations of those fail conditions. Dedicated data structures are another thing that you want to try and introduce at this point. In some languages this is classes, in other languages it's structs. But the idea is that we can replace, for example, associative arrays, hash maps, whatever you're using to store data that's kind of, that you can put anything into, and put it into some kind of structure where you know what data is in that data structure. And the other thing here is that in most languages at this point, you'll be able to add things like validation and common logic to that either object or structure, depending on what language you're using. And add your tests. This is a really good time to add tests, even if you don't test everything. If you've just broken a function down into 4 or 5 very small, easy to test functions, add those tests. It doesn't take a long time, and it helps to prevent regression. And it also gives you confidence going forward that when you next change this piece of code, you're going to have an easier time, because you're going to have some tests to run against to know that you haven't broken anything. Complete names. So this is not the end goal, but this is the end goal of kind of the refactoring of legacy into modern. At this point, you have modern code in the part that you've managed to refactor. You have modern functions, you have good data structures, you have good naming. You have readable code that you can immediately discern what's going on, and you have unit tests. The next step is to take us from expressing what we're doing to expressing why you're doing it. So complete names express what we're doing in the terms of the language of the computer, or the DSL of the programming language. If you're talking about storing something in a database, or reading something from the CLI, then you're talking about implementation details, and you're talking about implementation details that are specific to your program that you may even want to change later. Intentful names add domain context to the operations. So instead of having, for example, a store user in database, you could have register user. Expressing intent is useful for multiple reasons. The first one is that it makes it easier to abstract things and easier to encapsulate your logic and easier to segregate things based on intent. So for example, if you have a bunch of things to do with booking flights, you can have that entire bookings system segregated from everything else because you know that all of that intent is to do with booking flights. If you were to segregate it based on the fact that it's a database layer, transaction, UI layer, or processing layer, you have no way to segregate that out and therefore no way to pull it out as a service later on. So this is an example. What does this do? Don't answer if you came to my last talk. Does anyone know what that does? No? Okay. That's pretty much the exact same piece of code with intent added into the names. So as you can see from this, it's a foreign exchange transaction. But you wouldn't have been able to tell that from the one before because it's just not, it's not written in a way that's designed for you to be able to read it that way. This is also a good time to look at method signatures. If you're passing arrays that contain, or not arrays, hash maps or associatives or any kind of generic data structure into anything as a sort of a bag of parameters, put a dedicated data structure of some kind in, because that way you can use the method signature to express the intent. You can say, for example, book flight from this airport to this airport on this date, and it's far easier to read that you're booking booking a flight from this airport to this airport on this date than it is to book a flight based on an associative array full of parameters. And the next thing is abstractions. At this point, you have decent code. You have code that expresses intent. The next thing that you can do is start creating interfaces. So anywhere where you were previously talking about technology, where you were talking about SQL, where you were talking about CLI, where you were talking about web, you can start to put in interfaces so that next time it doesn't have to be SQL, it can be MongoDB, it can be Cassandra. Next time it doesn't have to be web, it can be mobile, it can be a desktop application. You can take entire context out because you've segregated by intent and make that a service. So if you do want to do your rewrite, one of the best ways to get a rewrite is to get everything from a specific part of your system in one place and then pull it out. And then from there you can do that refactor on a much smaller part of your system, which will be much easier to sell and much easier to do in a reasonable amount of time. And we can see where the logic is based on intent. We can move it. We can take, for example, technical language, and we can unify it. So if we see that we have 3 different ways of, looking up a flight, we can unify those into one and change all the callers to use a single source of truth for where we look up flights. So why refactor this way? It fits into your existing workflow. You don't have to try and get a budget for a refactor, try and get a budget for a project rewrite. It's streamlined, it's iterative. It's very easy to do most of those steps in 2 to 10 minutes. Once you've done the hard work of working out what something does, renaming it's very quick. And it delivers continuously, which again moves into the agile process. So we can constantly show value in that developers, instead of having to do the same investigative work that you've just done yesterday, when I pick up a ticket on the piece of code that you were just working on, you've renamed things and I can do that ticket twice as quickly. Do we have any questions?
What if you actually...
Hang on. You got a mic coming.
So say you picked up some legacy code, you've just walked into a company, they've got their code base, and then you actually start renaming things your way. To what extent have you experienced this before? Because quite often, when I've been there, I've seen the convention that they've used, I've kind of stuck to it just because it works, the software works, and it's especially for mature code. Whereas if you had everyone coming in there and putting their own slant on it.
So I've done this in a couple of places. You do have to get at least the development team to sort of agree that it's a good idea to change things. Because if they want to stick to a legacy way of naming things or a legacy way of shaping their code, you can't. It's not a solo effort. You do need at least the development team to work with you. But I have seen it transform 2 code bases and hopefully work in another one. Any other questions? No? Good. Thank you.